Topic 4-7, factoring completely. This topic can be referenced in our Holt textbook, Chapter 8, Section 6, on page 566. We're going to back up a little bit and look at something you may have learned previously is greatest common factor. You're going to look at the different terms of the polynomial, and if there's two terms only, then you need to look at possibly being a difference of squares. If so, factor it like a difference of squares, and we've done a few of those already. If there's three terms, then you want to use the box method, or if there's not a number in front of your x squared, that means it's understood to be a 1, you can try to do it mentally instead. But again, remembering the factor until you can't factor anymore, when they say factor completely. Okay, so look at this one. I've gone ahead and I wrote the box out because we're going to end up using a trinomial to factor. But first, you're going to look at what is common between every term in this polynomial. You would find that to be an x, because there's an x everywhere, and it's always the smallest number of variables there are. The exponents going up, you still have only one common between each term. The greatest common factor among 6, 3, and 18 is, of course, a 3. So a lot of times putting it underneath, like you're dividing, will help, because this is factored completely out of the trinomial, and then you just do the division. 6x to the 3 divided by 3x is 2x squared. 3x squared divided by 3x is just an x. Your 3's go away. And negative 18x divided by 3x is minus 6, negative 6. So now we have to look to see if this might factor more completely. Sometimes it doesn't, sometimes it does. You're going to put your 2x squared here. Enough practice doing that. You know your products are going to be a negative 12x squared. So the products this direction are also needing to be negative 12x squared, but an add-in of a positive 1. So think about what you multiply to get 12 that gives you an add-in of 1. So that's a negative 3 and a positive 4, because you want your x to be positive. And the x I'm referring to is this one over here. The middle term is made up of these combined terms, and you want it to be positive 1, but it also needs to match the products going this way and this way. They need to match. In previous lessons, I actually highlighted that. So if you want to think about this going this direction, and that going that direction, all giving you products of the negative 12x squared. They're going to give you that product. Okay, so now we're going to break it down. I wouldn't put the 2 here because there's nothing times 2 to get me to 3. So your 2x is going to go here, and your x here. This, of course, being a negative 3 times x, and this being a positive 4. So to factor this even more completely, make sure you remember to carry down your 3x, but it becomes the binomial x plus 4 and 2x minus 3. Alright, looking at this one, again, the variable x is common in both terms, and you can also divide out a 5. That becomes the outside of your, this one will end up being just a binomial at first, though, so be careful. This is actually, you need to always look when it says with exclamation points, remember to keep on going if it can. This is actually a perfect square. I can take a perfect square of x's and a perfect square of 1's. When there's no middle term, 1's a minus, 1's a plus. I went a little fast on that. If you need more explanation, see your teacher, but again, we're looking at a difference of squares. So make note that that's what you're looking at for this problem number 2. In this one, there's not an r in both terms, so the only thing that can be factored completely outside your parenthesis is just a 4 on this one. And then you're going to have 2r squared minus 1, which might look like a difference of squares, but there's nothing that makes this, you can't square root a 2. it is in its most simplest form as it is. So this would be your final answer for that. All right. Number 4. I've gone ahead and built their boxes for these. So let's just fill them in. You're going to put your 2x in your first box. I'm sorry, 2z. And your 15 here. This one's a large one because 2z squared multiplied by 15 is 30z squared. So you want 30z squared here also, but an add-in of an 11. Well, 5 and 6 give us 30, and if both of them are negative, I would end up with the negative 11 that I'm looking for in the add-in, but multiplied together, they're giving you a positive 30. Review your integer rules. 2 negatives multiplied together become positive, but on a number line, if I'm at a negative 6 and add negative 5 more, I'm headed this direction. So we got to remember that's different when you're adding them. So breaking this down, your 2 would definitely have to go here, and your z there. This would be a negative 5, and this would be a negative 3. So your factored form is z minus 3, 2z minus 5. Alright, looking at this one, you can factor something out. So let's look at that. What goes into each of these, think carefully, would actually just be a 4 and an n. When you do the division, 8n to the third divided by 4n is 2n squared. 44n squared divided by 4n is 11n. And 28 divided by 4 is 7. Your n's actually cancel each other out. This, however, I'm going to go ahead and put it over here. We can kind of look at it. Your products are 14, but you have to have an add-in of 11. Well, there's no product of 14. 14 and 1, 2 and 7. Nothing's going to get me to 11. So this answer is not prime. That's a prime number. So this is completely factored, as it's going to get. That is your complete factorization right here. So let's look at this last one. If you think about what can be factored out, the only common term is a 4. There's no v in the last here, so that you can't factor out the v. So this becomes v squared minus 10v plus 9. This, however, if you can think about it mentally, your v can go here, and let's think of this. If I need it to be a negative 9, a positive 9 but a negative 10, the factors of 9 and 1 multiplied together give you 9, but if both of them are minus signs, I could get negative 9v and a negative 1v would give me a negative 10v. So that checks out. And that is your, make sure you remember to bring the 4 down. This is your final answer, factored completely. Okay, this is a little bit of a review. Oftentimes on standardized tests, when they talk about the sides of a piece of cardboard shaped like a triangle with the ratios of 5, 12 to 13, what they mean is your scale will just use a variable x for our scale. So one of them is 5 times to 12 times to 13. The values of our scale stays the same, but our side, the lengths vary, but the scale stays the same. So our shortest side is definitely going to be this one. So that after we solve for x, we're going to have to make sure we plug it back in. But when you add these together to equal our perimeter of 60, you're going to get 30x is equal to 60. So x is equal to 2. 2 30s make 60, or divide by 30 on both sides. But don't say that the answer of the shortest side is 2. You have to put it back in and say 5 times 2. So that final answer would be 10, and this is in, it's always good to label it, feet. And that concludes 4-7.